Hi, everybody. Welcome to the Cisco sponsor track sessions. Thanks all for coming. We've got 4 great sessions today. If you have the little card on the seat next to you, you can find out what's coming up next. We're going to start out with this one here. We've got a session with one of our customers, Equinix, in a little bit. We're going to be talking about deploying Kubernetes containers, talking about SD-WAN. So please join us for all 4 sessions if you can. My name's Gary. I'll be your host for the afternoon. Just purely out of curiosity, yesterday in the keynote, Jonathan asked the audience how many people were here for the first time. And I was very surprised by the number of hands that went up. It was great to see new people coming. This is my 12th OpenStack Summit. So, out of curiosity, who here has been to more than 5? Chandra, stop. More than 10. You, sir. Okay, which was your first? Yeah, but no, which summit was your first? Paris. Okay, I still got you beat by 1. You're a little something from Cisco. Very quickly, I'm going to introduce Vamsi Kuppur, product manager out of our Cloud Platforms and Solutions group. He's going to introduce his co-presenters, and we're going to get the show on the road.
Yeah. Good afternoon, and thanks and welcome. With me, I have Dimitri, technical marketing engineers from Cloud Platform and Solution Group, responsible for NSO and DSC. And we have a guest speaker from Altiostar, Sanil, Director of Engineering. Today we are going to talk about how Cisco and Altiostar is enabling Rakuten to build their fully virtualized mobile network. By now, most of you guys would have been familiar with who Rakuten is and the announcement they made early this year in MWC about the launch of the mobile network. So when Rakuten decided to build a mobile network, they decided to go full virtualized, go and build a fully virtualized network. And the key tenet of building such a network is having a common telco cloud platform. And they chose Cisco NFVI, powered by Cisco Vim, to provide that common telco cloud platform, which will run all the virtual applications, or network functions, if you will, starting from RAN to the core. It includes the virtualized RAN, and the virtualized RAN is getting virtualized for the first time in the world. And Rakuten is the first one to do that with the Altiostar solution. In fact, when they started exploring this last summer, most of the vendors didn't believe in it. Today, we have the first fully virtualized RAN running in the commercial networks of Rakuten on NFVI, Cisco NFVI telco cloud platform. So if you look at Rakuten's cloud platform, it's built on 3 fundamental principles. Having a distributed and common telco cloud platform, to build a software-defined programmable infrastructure, providing a zero-touch end-to-end automation and assurance. If you look at the vision of anywhere, any services, primarily resides on these 3 principles. Let's take a quick look at the NFVI architecture behind Rakuten's telco cloud. So this largely maps to the HC reference framework. The NFVI hardware layer, they have their custom-made x86 servers for compute and storage, and they chose Cisco Nexus switches and ACI for the networking. And for the Vim, they went with Cisco Vim, which is going to provide that common telco cloud platform. And of course, it's powered by OpenStack. On top of this platform, they have various applications from Rakuten, from Cisco, and other third-party vendors, including Altiostar's vRAN, running on top of this platform. As part of the Managed Stack, they have Network Services Orchestrator from Cisco to provide the NFVO core functions, and Elastic Services Controller as their VNF manager. And there are other third-party VNF managers, too, in the solution. So the goal here is to provide a model-driven orchestration with a greater flexibility and elasticity. Today, for the rest of the presentation, we are going to talk about three key building blocks. Cisco Virtualized Infrastructure Manager, the common telco cloud platform, NSO and ESC as part of the managed stack, providing that end-to-end automation of services and infra, and virtualized RAN from Altiastar. So when you're trying to build a fully virtualized mobile network, the problem statement of that common platform translates into having a platform which can run various applications at various locations. When you look at these applications, they are quite different, and they vary in their requirements from the infra point of view, and also they have very different scale requirements. And they get deployed at different locations too in the network. And when you look at those sites where they get deployed, they're very different from traditional IT and data centers, IT data centers. And also these sites vary in the characteristics when it comes to physical space and other constraints and power constraints and so on. And the scale requirements are also differ quite a bit. So Rakuten is trying to build this huge network. Like the scale of this is like they're talking about thousands of edge sites and like tens of regional data centers and large central data centers. It's more like a hierarchical cloud they're trying to build to realize this virtualized mobile network. So like when you take those things into perspective and see like how should that cloud platform look like. When we started CVIM, the very first deployment model we supported was the typical deployment model, which we call it as full-on, where you have dedicated servers to run your control functions, and servers to run your storage, and servers for your compute. That's the typical OpenStack deployment model. And then when we started looking at use cases like packet core and so on, like where the VNFs doesn't have huge storage requirements, we decided to kind of optimize the footprint by enabling compute on the storage nodes. We call it as hyperconverged model. And if you look at the scale characteristics of these two deployment models, it's pretty much the same. And they fit very well in regional and central data centers to run the applications like packet core and other core applications. And then as we started evolving towards the edge use cases, we further optimized the footprint, and we came up with MicroPod. This we launched like a couple of years back, where you have a fully functioning cloud with 4 servers. So what we did is we collapsed the control, compute, and storage functions onto 3 nodes. And then you have one additional management server to deploy and manage that cloud. And optionally, you can expand the MicroPod with additional computes, dedicated computes, up to 16 computes if you have to augment this compute capacity. And then when we started looking at use cases like virtualizing the RAN at cell sites, the footprint needs to be optimized further. And these sites are constrained by space and power, as I said, and also the hardware that goes into these sites are very inexpensive. So to an extent, like they won't even have multiple drives to have a storage solution on those servers. So then we introduced the edge pod early this year. That's what is being deployed across thousands of edge sites and Rakuten network, where you have like 3 servers on the site which will run your control and compute. And we created a central storage cluster to provide the image services through GLANCE. And in this deployment model, there is no persistent storage or like Cinder services. In fact, the applications that are going to run on this, at this site, they don't require any persistent storage. So by centralizing the storage and the management and having just 3 nodes, again, like very inexpensive, like small servers at the cell sites, we optimize the footprint further to address the use cases of forage, like running vRAN. So like with these 4 deployment models, we can go from forage back to your data centers, running various applications like 80+ different VNFs that runs on Rakuten mobile network. So when you ask why to virtualize or why to fully virtualize a network, it's just not because virtualization is the coolest and greatest technology out there. The main outcome, like if you ask Cisco or any of the service providers we work with, is like operational efficiency. So that is the key thing like they're trying to achieve by virtualizing their networks. And like when you want to achieve an operational efficiency across your network, the platform, the underlying platform has to support that. Cisco Vim, if you have been following it, like it's been out for almost 4+ years now, and it has a large deployment across multiple service providers across the globe. It's been built on a containerized architecture, and it provides a very fully automated and a predictable way of deploying and managing the cloud. It comes with a suite of integrated tools to validate your data path and control plane. There are two things I would like to highlight today as part of the things that Cisco Vim brings to the table is like the centralized management and CVM monitor, which actually helps to realize that operational efficiency. As we saw in the edge part deployment model, like where we centralize the management, that gives that capability of like, it's just not optimizing the footprint, but now you have a central management plane from where you can go and deploy and manage this multiple sites from one single point of management. CVM Monitor provides that centralized monitoring solution to monitor your distributed NFV cloud deployment. It monitors your physical, virtual, and application layer. It also integrates into your OSS system to ensure that, or to realize that end-to-end assurance. So when we talk about 5G, the first thing comes to our mind from technical point of view is containers and container network functions. So Rakuten has chosen to go with 5G architecture from day one. They're rolling out their 4G, but they would like to have a seamless upgrade path to 5G as they evolve their networks. So for that, the common platform should be able to run both the virtual network functions and container network function next to each other. Cisco Vim today is a virtualized platform on which you can run your virtual network functions. Later this week, we are launching our Kubernetes support on Cisco Vim. It's actually powered by Cisco Container Platform. In the first release, the CCP, the Kubernetes cluster, is going to run in OpenStack VMs. And in subsequent releases, we will offer the same CCP on bare metal. As shown here, like the bare metal is going to be managed by Aeronix services. So having this kind of a converged platform which can run various applications ranging from vRAN, packet core, PCRF, policy applications, AI and ML kind of application, but also different workloads like VMs, containers, and bare metal, and having this for deployment footprint, and that can fit into your edge, far edge to your central data center, is kind of the key tenet for having a common telco platform to realize a fully virtualized mobile network. Now I'll hand it off to Dimitri, who's going to talk about NS4 and DSC.
Hello, everyone. Can you hear me? Or, okay, I'm getting this funny echo. Well, welcome, everyone. I'm going to be talking about Cisco's Network Services Orchestrator and the Elastic Services Controller. These are the two products that we have in, sorry, the other way around, that we have in the deployment with Rakuten, and they're all about management and orchestration. So, what do the two products bring? These are the products that Cisco has for management and orchestration. As I said, first and foremost, automation. The whole idea is to have zero hands on the instantiation of these services in the network. So first and foremost, NSO and ESC provide automation. It is a cross-domain, multi-vendor solution. For those that haven't been through the Cisco booth, I'd urge you to come by booth A9. We can give you a more detailed demonstration about NSO and ESC and the capabilities of the two products. As far as integration is concerned, they do offer a consistent and simplified automation of both your physical and your virtual workloads. Today, in order to instantiate services, you have to account for both these types of infrastructures. So NSO and ESC are a perfect fit. Northbound, we do offer a series of different programmatic interfaces, so it enables to have a clean OSS integration. And for also, very important, you can horizontally scale the solution to accommodate future requirements as your networks expand. This is a more detailed view of what Network Services Orchestrator offers and what it comprises of. You'll notice on the left-hand side of the slide, there is a set of elements that provide device abstraction. These are called network element drivers. This is part of the secret sauce that makes NSO a very powerful tool. Each network element driver represents a family of network operating system. And by that I mean we have network drivers that can support various vendors. So we would have a network element driver for Juniper, supporting the Juno OS. We have network element drivers supporting Huawei, Ciena, etc. We have network element drivers almost for any vendor out there that you can think of today. And if it's not already available, it will become in the roadmap. These network element drivers are responsible for talking to the infrastructure. And the infrastructure can be physical, can be virtual, could be software. We have a network element driver, for instance, to talk to OpenStack if we need to provision OpenStack. They are very competent in actually talking to the infrastructure. But another important feature they do have is that they can translate that infrastructure into models. So when you're using NSO, you no longer have to be aware of the intricacies of the network operating system in the infrastructure. You are internally now using models. And what that allows you to do is a very efficient way of designing services. Because within NSO, we also design services using models. For NSO in particular, we are using the Yang modeling language. I don't know whether you are familiar with Yang, but it's becoming a very popular modeling language. It's been accepted and used by some very important network vendors. And as I said, it is a core part of the tool. The moment you have Yang as the model language, you can do very interesting things. So at the service level, as I said, you can design it in Yang. And at the device level, which is also in Yang, you can make very quick comparisons about what my network state looks like and what it should be based on what my service intent is. All the information about the underlying network is stored in a component that is here reflected as CDB. That is our configuration database. Anytime that NSO talks to the infrastructure, stores that information into the CDB, into the configuration database. Every time it tries to talk to a device, it compares what it knows about that device and what is actually in the device at the time of the conversation. So it can alert you about inconsistencies. Another important component in the stack is the Elastic Services Controller, which is our generic VNFM manager. The VNF manager is responsible for the life cycle of all the VNFs that we instantiate in Rakuten environment. We have a built-in monitoring service that will communicate with all those VNFs at a periodic time that you can configure, and it will check things to make sure that the system is up and available. A bit more information about the Elastic Services Controller. So, as I mentioned, full lifecycle management on the VNFs, or VMs it may be. It is modular, it is open, it is API driven. Both NSO and ESC have interfaces exposed northbound. There is a tight integration between the two products based on NetConf and Yang that I mentioned to you earlier. ESC is compliant with ETSI MANO. So we adhere to the ETSI MANO standard specification for management and orchestration. So ESC is a product that complies to that management and orchestration stack. It does intelligent VNF placement, and the placement can be based on a number of parameters, whether it is workload, whether it is capacity, whether it is specific requirements that you might have from the infrastructure, depending on the requirements of the VNF. It has an advanced healing and monitoring system, as I mentioned earlier. So ESC is capable of looking at devices that might be depleted or VNFs that are out, not performing as expected, and it can scale them by spinning up additional resources as per the requirements. And obviously, we do support some analytics, and we have also customized rules to address corner case situations that you might have for your deployments. In this slide, we're showing how the horizontal capability has been implemented in the Rakuten environments. So at the top level, obviously, Rakuten has their own OSS and BSS systems, but immediately after that, we have the Cisco NSO acting as the master service orchestration tool. Depending on which domain or geography we scale out NSO systems to accommodate that geography. Here we're looking particularly at the central DC, which has its own dedicated NSO system and ESC system as well. We also have the wide area network, edge DC, and the far edge DC. All these local NSOs have absolute control of the resources within their domain, but they also reference these resources to the master NSO system, which is driving the overall automated orchestration of the solution. And with this, I would like to hand it over to our honored guest. Thank you.
Thank you. Hi, my name is Sanil. I am from Orchestration. Orchestration is a small startup focusing on virtual LAN development. And as mentioned, we are working with Cisco to deploy vRAN in Rakuten network. Oh, sorry. So I'll try to give a little more detail into virtual RAN. Some of the constraints and challenges in deploying virtual LAN. In fact, in the mobile network, RAN is one area which which is getting virtualized now, and it didn't get virtualized earlier because of the challenges it faces. There are a lot of constraints in compared to other virtualization. So I'll just briefly go through some of those points here. First of all, vRAN, what it's trying to do is not just virtualizing it. You have to first take this monolithic proprietary kind of implementation which is there and decompose into virtualizable functional unit and provide openness of interfaces so that it can interwork between this functional component. So in the standard, they talk about different split. The split is basically, if you look at it, there is a centralized unit and distributed unit. That's how the RAN is split into different functional blocks. And the different type of split basically is decided based on what kind of functionality fit in the centralized unit, what functionality goes into distributed unit. And in Rakuten deployment, we are following split 7.2, which you can see there is some upper control layers is sitting in the centralized unit, and most of the lower layer, the PHY, MAC, and the RLC layers are sitting in the distributed unit. Now, when you talk about the distributed unit and the VNF deployment, there are a bunch of constraints for deploying those units. One is the front-haul latency, the latency of the interface, which is really connecting the antennas, the radio unit in the VNF. And there is a constraint of latency. You can have only 250 microsecond budget. So you cannot really take that VNF or the data center far away from the cell site. And also there are other constraints in distributed unit. it needs some real-time processing requirement in the VNF. And that's a challenge where Red Hat or Linux and the OpenStack doesn't really support that naturally. So there are some enhanced platform awareness, CP pinning, NUMA, etc. need to be enabled, and also DPDK to get that level of real-time processing requirement in the distributed unit. So this gives a little bit of the overall architecture, how these different elements are deployed in Rakuten network. As you can see, the cell site has a device called RIU, which is sort of converting the cell site transport into something understandable for the networking, the Ethernet. So it's kind of convert what they call CPRI frame into eCPRI, which can be transported over Ethernet transport. And Ethernet transport front haul takes the traffic into VDU, which is deployed as VNF in the far edge data center. And there are other VCU VNF, which is more a controller aggregating those traffic. And then over backhaul, that traffic goes to the regional data centers and back to the central data centers. So this picture gives a little bit the context into how this whole network is distributed. Mobile network by nature is geographically distributed. You are really covering a large geographic area. Now, added to that, as I mentioned before, there are some latency constraints. You had to put the far edge or edge data center very close to the cell site. That's a big challenge. So that really, so when you look into it, there are probably 50 to 100,000 of cell site in the network. Here it is deployed in Japan. So this Rakuten network is the kind of number to give the scale of the number. So we are talking about 50 to 100,000 cell site, which is now connecting to around, let's say, 5,000 or so edge data centers. And then that again aggregated into regional data centers and finally into central data centers. And you can have a couple of huge central data center aggregating all this traffic and also running a higher level management and control functions and other packet core functions in the central data centers. So another point I want to really stress here is just as you can see, there are hundreds and thousands of elements in the data center and VNF running. Manually managing those radio networks or data centers or VNF is not at all possible. So automation is very essential, really running these kind of networks. And virtualization, in a sense, is enabling this automation. But automation sort of then speed up the pace of deploying this network. So here, this is something already like deployed in Rakuten. This gives an example of how a single radio site is completely auto-commissioned without any manual intervention, right? When you switch on the radio site, it really automates the whole workflow to really become active. There is no manual intervention needed. So somebody needs to really put that cell site and switch it on. Everything happens. So there is an animation here. I'll quickly go through it to give an idea, right, how this is all going to work. So first thing happens is obviously the cell site is switched on. The first thing he's trying to do is he's trying to get a address. He will go to a DHCP server and get an address. DHCP server will give some additional information like the EMS server it should go to. And then that RIU device, which is sitting in the cell site, will go to the EMS server and register saying that I'm really up, I need configuration, and I need the VNF, etc. connectivity. So EMS will look into it and see whether there is already a VNF running, VCU video VNF running to serve it. If not, it will instruct the NSO and ESC, which are the orchestration component of the network, to deploy a new VNF for this to serve this cell site. And that's what you can see. The central data center, the ESC NSO running in the CDC will instruct to instantiate a new VNF in the far edge data center. So here a new VNF is instantiated for VCU and video. So at that point, the VNF will then go again back to EMS and OSS to really get the configuration to run that VNF. And once this new VNF is auto-configured, then the VNF will instruct or provide the configuration to the RIU so that the cell site is now fully configured, and now cell site becomes active. So here, this is something already deployed, and there is no manual intervention at all. So this is key because there are a lot of talk about really automating a radio network. I would say this is probably the first time this is deployed to this extent in an operator, this level of automation, where completely a cell site auto provisioning is done without any manual intervention. So that's all I have as slides. I think we can open up for questions.
We have about 6-7 minutes for some questions, if anybody has any. You know what? I will come to you.
So Sanil, can you explain, the DU CU split in terms of where it's deployed? Is it a cell site or is it at the far edge?
Okay, let me go to that slide. Sorry, so I'd go back. So what happened? So sorry. Can you go to that slide? Yeah.
This one?
Yeah, that one. So the question was about the split between CU and DU. CU is a centralized unit and a DU distributed unit. And so the reason we went for a 7.2 split basically is that the RF or the antenna is running pretty much very minimum intelligence. It just has the radio, and it's really getting that signal. And there is a unit called RIU, which really converts that radio signal into eCPRI, which is sort of can be transported over Ethernet interface. So it's pretty, I would say, dumb, and there is not much software there. It's very low-cost hardware we can run in the radio site. And the baseband processing is all done in the video, where you can see this is the middle thing I'm talking about. The higher layer of the PHY, MAC, and RLC is all run, the scheduler all run the video, which is also virtualized. So again, this is probably the first time it was done. Typically, what they are trying to do is the DU is not virtualized. DU is hardware, which is sort of put with the cell site. But here in Rakuten, even the DU function, which is challenging to virtualize, is virtualized and put into the cloud. And that's the unique thing. And now what happens is the radio site has a very minimum kind of footprint, just the radio and a small unit which converts the signal. And then you have the centralized unit, which is running layer 2 and layer 3 of the radio network, which is the CU, where you will see RRC and PDCP layers are running in the CU. And DU and CU altogether constitute an E node B in a traditional way, or G node B, if it is a 5G network.
So this architecture requires that you have fiber between the radio unit and the far edge. If you don't have fiber, or fiber is not there as much as you have in the US, then can you deploy this architecture?
Yeah, so obviously, as I said, there are constraints, So this assumes that 250 microsecond budget, So obviously, you probably need a lot of dark fiber. And that's what I said, like, can you have data centers? Do you have dark fiber to the cell site, right? So this is one model. Another model is split 2. If you go to split 2, where if you don't have that level of fiber, and if the cell site is slightly far away, you had to go to split 2. We even support that in Rakuten, a small cell and some other regional or rural data centers where there are not enough fiber will use split 2, where DU is running with radio, and that you have only like a 50 millisecond budget, so you are fine running it over a regular network or transport.
Okay, sure. What is the deployment base or scale that can, in terms of the number of subscribers, based on your trial, that can be supported on one like a far edge cost server with I don't know how many videos you're going to run on one cost server? I think you have done the trial, right?
Right. So yeah, okay. The trial is going on. So we in Rakuten there are different type of far edge data centers. There is like A to F or a number of different things, and it can be sized based on number of sectors or number of cell sites you need to support, right? The smallest one, I don't know, Chandra, 8 cell site, right? Smallest one, 8 cell site, and it goes to, I don't know, some 32 cell sites. So it's sort of really sized based on number of sites available and number of data centers available, physical data centers, and the number of sites you want to support, right? So it's a very variable thing. Maybe Chandra can provide a little more information.
It's based on geography and location. Like Tokyo has much higher density. So like Vamsi had said, like initially you can start with a 3-node system. That's the 8 cell site. It has a redundancy built in on the server as well. But in Tokyo and even Osaka and many of the high density population area, you can actually extend all the way to 16 more computes. And that way you get your more cell sites. And then obviously they're planned so that there is a shadow of each other. So there is a handover that can also happen. So that's the high density. But 75% of Rakuten sites, 75% is the small 8 cell site model. It's only the 25% which is the high density. But area, if you look at the rest of the country, 75% is this very, very small, so 8 to 16 cell sites max.
I have 2 quick questions on the packet code side. So when you are mentioning about bare metal and the virtual machine, so in use cases like UPF, you want to install it, right? So which one is your preferred way? Because you need high throughput and better latency and all those constraints for the UPF. And then another question on the same line on the UPF, when you are installing it on the edge, so what you are going to do with all the overhead of controllers? Are you going to manage them remotely? And how your architecture will look like on that?
Chandra, you want to take?
So one of the unique things that we have done in the Rakuten project and in Cisco Vim overall is it is 100% automated. We've also optimized the overhead of controllers. So in the very edge, power and amount of space available is very, very critical. These are not even Rakuten sites. These are entity sites that Rakuten has leased. Per rack, only you can do 4 kilowatt hours. That's pretty much it. Even the size of the servers are small. So we worked with Rakuten and Quanta and all of the, and Orchestration and various other vendors so that the control and computes are running on the same hardware. It is a so if you look at what Vamsi had said, the evolution of the pod, we've gotten a full-on where everything is separated, controls and compute and storage is separated. And then the next is micropod where all 3 are collapsed. There isn't enough hard drive to even support Ceph here. So we just did control and compute. This and the Orchestration VNF doesn't need any persistent storage. We talked to the CDC to fetch the glance image over IPv6, you know, and as long as 50 milliseconds, which is perfectly fine. Dark fiber, one thing is in Japan is very cheap. It's $30 per month per rack, very cheap compared to anywhere in the world. So that's an advantage they have. So to your point, that's how we have reduced the form factor. The second thing you said is in the CDCs running the VPC and IMS and all, because of high throughput requirement, all of them are running over SRIV. So even this particular AltioStar's video VCU, there is the actual data packet is coming over SRIV. So that's how we have cut away the virtualization latency. No, just computes. When the VNF comes, you can use the provider network and bring in SRIV. The reason why, again, we don't want to go through, what if there's a bug in Ironic? So we want to get virtualization. If it's SRIV, cut through all the way. You have a compute, you have VM, you cut through all the way. It's an easier overhead. We support Ironic in the CDCs also, but that's for a different purpose. If the VNF needed such that it was the complete compute and they don't want any virtualization, but they want VirtIO, that's when we are giving Ironic. Okay.
We're going to have to, because of time, we're going to have to move Q&A out into the hallway track, if that's okay with anybody who still has questions. As Dimitris mentioned, if you have more questions about either our NSO product or our CVIM product, come on down to the Cisco booth in the marketplace, booth A9. We have demos going all day. That's probably why they're a little hoarse and have sore throats. But thank you for coming. We have 3 more sessions coming up today, so pick off the menu and come back and visit us.